All right, last thing we want to take a look at is multi-step synthesis and kind of combining some of the material we previously learned with some of the new material to learn how to make some new compounds and do some little tricks, right? So remember before we have alkanes. There's really only one thing we can do with alkanes, and this will be pretty much true for the whole course, and that's make them into haloalkanes. And whenever we make them into haloalkanes, we don't have that much control, right? The halogen is going to go in the more substituted position, and that it is what it is, right? That's all we can do there. And from these haloalkanes, we can do substitutions, right? SN1, SN2 reactions to insert different types of functional groups. Or we could do elimination reactions to form alkenes, right? We already previously knew all of this, but now we can go back from alkenes, right? We can make alkanes if we wanted to through hydrogenation. We can go back and forth between alkenes and haloalkenes through addition reactions, right? And so this will be really important because this will allow us to shift the position of our haloalkane. And then, of course, we can go from alkenes to some kind of functional groups, right, by adding alcohols, ethers, or amines. So let's go ahead and take a look at that, right? One of the most kind of cool tricks we can do is moving our double bond or leaving group. So for example, if I told you that you're starting off with this alkane, and then I want you to propose a series of steps that will eventually lead us to this compound at the end, right? You can see the difference is the addition of this bromine, right? But we can't go there in a single step, right? There's really only one thing we can do with alkanes, and that's essentially to brominate them, or chlorinate you can too, but bromination is always better. And so if you have an alkane, you can pretty much be guaranteed to always start with a bromination, but think about where that's going to lead you to. That's always going to put that bromine in the more substituted position, right? And so how are you going to connect this haloalkane to this haloalkane? Well, it's like we talked about, right? We can go back and forth between these alkenes and these haloalkanes, and we can do so specifically because now we've learned a number of different reagents to do this. So for example, we can do elimination reactions, right? Maybe something like sodium hydride. This will form our more substituted alkene, right? And so now we can see we're a little bit closer, right? And so of course we can't add Br over here yet because we don't have an alkene, but we've learned how to add a Br here or here, right? If we add it to the right side, we're right back where we started. So we want to go towards the left if we can, right? And if you think about how we're going to do that, we're going to do that through an anti-Markovnikov addition. And so we're going to go through this radical mechanism to end up with this bromine right here. And then how are we going to get even further? Well, think about we're just going to repeat these things again, right? So we're going to want to do an E2 elimination, right? But if we insert a double bond here, we're back where we started. So we need to go the other direction, right? That's the Hoffman product. So you're going to need some kind of bulky base, maybe some kind of DBU or something like that. That'll put your alkene right there. And as you can tell now, we're getting closer and closer. And of course, then we can do another anti-Markovnikov addition to get to our final product, right? So you can see how we can move these double bonds and these leaving groups to essentially wherever you want to do them, right? And then, of course, there's a whole bunch of different other stuff you could do. My recommendation is to just start with an alkane, brominate it because that's the only thing you can do, and then just start picking random reagents and then just start stringing them along together. That's how I come up with a lot of these problems. It's kind of just like pulling a hat out of a bag. Eventually you'll get somewhere, and it's not too bad, right? But when you're thinking about solving one of these problems, one of the key things that you want to do is think backwards. Backwards and forwards, I would say. Oftentimes, it's difficult to go from the start all the way to the end or from the end all the way to the beginning, but you can get halfway there from each step and then meet in the middle, right? So let's take a look at an example of this, right? We see we've got this cyclic alkane, and then we've got this alkane with some aldehydes on there, right? And so we see aldehydes, right? That should kind of be a hint. What kind of reaction gives us aldehydes, right? That's going to be oxidative cleavage. It's pretty much the only reaction we've learned that can add aldehydes, right? And so remember that was with ozone and then some kind of reductant like zinc and water. And then we think about how long this carbon chain is. 1, 2, 3, 4, 5, 6, right? And so our chain is going to be 6 carbons long, right? Where we're going to start breaking apart this chain to make our aldehydes. And so we can kind of start thinking going backwards even further. Here we've got an alkene. And so we're going to do some kind of elimination. But think about, we have multiple different things to eliminate, right? We could eliminate a halogen, or we could eliminate an alcohol, right? So you've got multiple options. If you've got multiple options, sometimes it's good to start at the beginning. And so here in this pathway, we have an alkane, right? And again, there's only really one thing that we've learned how to do an alkane with, and that's basically add bromine across it, right? So that's pretty much the only thing you can do. You could add chlorine too if you really wanted to. It's a little bit less controlled, but it's fine, right? That's pretty much the only thing we can do with a haloalkane. And so we can see, in order to connect these two, we need to do an elimination reaction. So we just add some kind of base. It doesn't really matter what kind of base it is. But you see, by going back to the beginning, this told us that we need to come from this haloalkane and not come from some kind of alcohol. You could come from some kind of alcohol, right? But then you're going to have to follow a number of different other steps to get there. So it's good to pick one side, the starting material or the ending products. Generally start with the end product and start working your way backwards. If you get stuck or you have a whole bunch of different options, then go back to the starting material and see what kind of options you have there. And so here we have this alkene. And we eventually want to end up with this end product, right, where we're also getting the enantiomer as well. And so if you look at the relationship between these two, right, this is a 5-member ring with essentially a 6th carbon attached. And here we've got a 5-membered ring with a 6th carbon attached, right? So what's the difference between these two? Well, it's this addition of these alcohols. And we can see that we have an anti-addition, right? One's a wedge, one's a dash. So we've added them in opposite ways. And so if you think about how we're going to do that, that's going to be through our epoxidation and then our acid catalyzed epoxide ring opening. And so if you think about the product before that, it's going to be our alkene, right? The MCPBA first makes the epoxide, and then the H3O plus does an acid catalyzed opening, right? And so now we see again, we're at an alkene. And in the beginning, we also have an alkene, but they're in different positions, so we need to move our alkene. Right, and so we need to do these eliminations / addition reactions to get it to go where we want it to go, right? And so in order to form an alkene, you need to add some kind of base, maybe sodium hydride. That's just my favorite base. You can use a different one if you'd like. And then think about where your BR is going to go, right? You can put it either here or here, right? It doesn't matter. Oftentimes there's multiple correct answers. If you want to know if yours is the correct answer, just ask away. But we could put the bromine here, add some sodium hydride, and we'll make this alkene over here. And then we think about how can we connect this bromine to an alkene? Yes, we can, right? That's done through some kind of bromination, right? In this case, we see that our bromine is in the more substituted position. And so we're going to want to do some kind of Markovnikov addition. And so here we're going to want to add some mercury acetate. with some water, and then our reductant, our sodium borohydride, right? Oops, my bad. That would add NaOH, right? What we really want to add just here is actually HBr, right? That'll give us our Markovnikov addition. Right, and so again, really, it's just you need to be familiar with what kind of reagents you can do, what kind of additions they need to do, and you want to take a look at your end products, see how it's different from your beginning products, and try to link the two. Really, all of this comes down to practice, practice, practice.